So we're here at the CES 2019, and who are you?
Hi, my name is Jeanette Wilson. I work for Microchip Technologies. Welcome to the 2019 CES. Let me show you our booth.
So you have lots of demos around here?
We do. We have a lot of demos on here. Microchip is a semiconductor company, and we really focus on effortless design for our customers in the areas of smart, connected, secure. So what we're showing here is a wireless network. So MyWi is a Wi-Fi technology from Microchip. We also have LoRa, which stands for long range. If you need to communicate over a longer range, 10 kilometers, for example, you can do that wirelessly. And then through Wi-Fi. When you actually take a look at this demo, we're measuring the temperature in different areas of our booth, and I don't know how this will show up on your screen, but you can see the different hotspots and where we're located and the temperature that's being monitored.
Nice.
Over here is an example of a device using our PIC 24F J64 GA702. Now what this is an end application. It's one of our customers' designs right here. This is a 16-bit microcontroller, and it's really being used to monitor the overall health of animals in the industry. So this will be very important for dairy cows when they're looking at the production of milk. You can think of it as a factory, and so this technology helps them to be able to maintain and monitor the health of the animal.
Nice.
Over here, I'm just going to hit these very quickly, but we have a lot of sensors in here that if you're looking for precision control in your industry factories or anything like that, we're able to very, very tightly monitor these.
This is like a weight measuring system right here?
Yeah, so it's got a scale on it right here, so you can see this. It's also going to do some different cycling here. And what we do is we do a lot of different designs too. You can see we have a lot of different Microchip devices here, and so we try to package them together very easily for our customers to be able to use these.
What is this?
This is a gigabit Ethernet network redundancy.
Yeah.
And what's nice about this is when you have a ring network, sometimes things go wrong in the factory, right? Maybe you lose control or things like that. Let's just say something happens and something gets broken. I can pull it out. And if you see over here, it recognized that it broke, and so it's going to now try to self-heal the ring using this ring technology. So
kind of like meshing or rewriting.
It's not a mesh, it's actually a ring technology that we're using for this, yes.
Nice.
So very similar in terms of the Ethernet here.
Yeah.
Over here what we're showing is Amazon free RTOS. So a lot of our customers are very interested in how do you connect to a cloud. And as a semiconductor vendor, we are cloud agnostic, but we have a lot of examples. It looks like this one's being very interesting right now. So let me show you this one. Now this one is based upon a CEC 1702. This is an ARM M4 core with hardware cryptography in it. And with hardware cryptography in it, what it means is that when you're doing hardware algorithms, for example a SHA, to do it in software will take you about 186 microseconds, versus doing it in hardware is 33 microseconds, or a 5 times difference. When you start to do encryption and decryption of your data, you can start to see the scales. Because it's a general purpose microcontroller, there's a lot of things we can do, but a lot of our customers will use this to do secure flash updates and make sure that you've got updates that are good, and then secure boot. We can also do keypads because we have a lot of I/O on this device, so we can actually use this to control different things with a keypad. So you can see some of the different things there.
What is this single board computer here?
So this is a single board computer from Congatech.
Yeah.
Yes, absolutely.
Where is your solution here?
So our solution is the MEC 1705. This is also an ARM-based product. These will be used in conjunction with Intel architecture, and Intel's in a transition from one bus to a new bus called eSPI, and we're one of the first manufacturers to have that eSPI capability, and as such our customers has used this. And then it also has the capability to do secure boot, so if you're worried about rootkit types of issues like the Stuxnet virus or things like that, it will then...
Did you say eSPI?
Yes.
So, and this bus solution means, what does it mean? The multi-bus, or is it what? I see 2 chips here.
Right. These are actually the Intel chips right here.
There's 2.
Chip, yes. So our chip should be this one right here. I'm struggling to look at it right there. So, and so what it's really doing is that as the process nodes shrink down below 10 nanometers, physics change, and so you can't always support like a 5-volt bus, and so you've had to go down to a 3.3-volt bus or even lower bus technologies. And so what Intel and AMD have on their architecture has done is they started to transition to those buses.
Nice. And this was the one with the Amazon free. Why does this say Amazon free RTOS? What does Amazon have to do with the free RTOS?
Well, so Amazon free RTOS actually is a development kernel, so you can actually see this based upon the free RTOS kernel. And so the nice thing about it is it's very small and very lightweight. Very small and very lightweight, and so it's very easy to use with like the Amazon AWS, Amazon Web Services. So what this demonstration is showing is a development board using our Wi-Fi technology and a temperature sensor, and it's taking data and it's connecting up through the AWS cloud and coming back down here through the gateway and being controlled. And so what's being shown there is controlling this, and you can actually monitor the different temperature, humidities, and things like that. So that's what we're doing, is tracking that. And these 2 devices are actually talking to each other.
And you have chips on there.
We have lots of chips on here. So this is a PIC32MZ. We also have our wireless chips on here as well. We also have some other microchip components on here, so there's a significant amount of microchip content on here.
Right.
Over here we've got some very unique devices. These little devices here are the ECC 608 family of devices, which is fantastic for doing authentication.
Yeah.
And to really secure your system and who you're speaking with. In addition to this, we've got the microchip processors that are on here as well, 32-bit microprocessors on here. So we have all of that here.
Nice. All right, and you have more and more demos around?
I do. Let me show you actually some of these.
Is this an ARM solution?
This one, yes. So these are ARM solutions. Now these are the SAM10, SAM-L10, SAM-L11 devices, which has the trust zone in it. So what that allows you to do is it allows you to have a portion of the code that can really be protected in a customer environment, in a development cycle.
So it's not using the new ARM Cortex M23 or 33, but it's as a microcontroller with the trust zone built in, maybe?
It is, and it is...
No problem. And you also showing some right here.
Yeah, so this is actually showing water-tolerant touch demo. So the thing about touch is a lot of times it's very difficult to actually have water because water is a conductor. But even now you can see my buttons are changing even though it's wet. So it still knows what's going on, even though it's maybe in a harsh environment.
That might be also part of the firmware, how you have algorithms that can figure that out and stuff.
It is, absolutely.
Right.
Absolutely.
And over here?
And this is the SAM-L11. So this is showing an ultra-low power device right here. Now this is also doing secure LoRa, the long-range capabilities.
So this is an ARM chipset also?
This is an ARM, right. Chipset ARM trust zone with the immutable secure boot, and it also has some hardware cryptography accelerators and a true random number generator in here.
All right, and this is very important for the future of the IoT also, and the LoRa and stuff like that.
Absolutely, and you can see, we were actually a 2018 winner for the SAM-L11 Best Contribution to IoT Security, and that was from ARM TechCon. So, we're very proud of that award.
Nice, big partner with the ARM, right?
Yeah, absolutely.
Yeah.
Mm-hmm.
And you have more and more demos around?
Yeah, so here's more touch demos.
Yeah.
So, when you have different touch demos, again, I don't know if I can turn this one on. Sometimes in a harsh environment, like a factory environment, you may have gloves on to help protect the users, but sometimes you still need to be able to handle different things, and so you want to be able to touch different things, even though I don't have,
nice.
It's
not conducting.
Right. No, it's not conducting.
Plastic glove?
Yeah, just a plastic glove. Here, you can touch it, feel it.
And somehow it goes through.
Right, with the touch capability that we have. In addition to that, and I think that this is really neat too. Again, this is another customer of ours that's using our haptics technology. One of the benefits of touch technology is that it's quiet, but a lot of people say, well, I don't know if it's working. I can't tell if it's working. So these are really nice because they actually give you vibration, and unfortunately for the viewers on the camera,
Nice.
you can't tell, but when I touch it, it actually vibrates.
It's like,
Do you feel the vibration
Yeah.
when you touch it?
it's nice. So what do you
And
do
now
about that?
Do you also hear it? Do you hear the...
I can hear it, I can feel it.
Right.
So what do you do about that?
Well, and that's part of the haptics technology that we've incorporated into our solutions. And so what it does is it gives the users the ability to actually feel and sense these technologies that are associated with this.
Nice. And this is maybe potentially could also be printer electronics and stuff, or like it looks, it could be like in a, I don't know, in the shower or something.
Absolutely.
It's maybe waterproof. Maybe. But then here you have some other...
Yeah, this is also another waterproof technology, similar to what we've shown you before. So again, you know, you can do different things, and this is just showing that even when I touch it, I can still work.
Nice.
So, yes.
Cool.
Yeah.
All right. So maybe we can walk around a little bit
Yes.
more?
And actually, I think that Brian will actually be sending you, and we're going to have a different person for you to show you our fascinating automotive solutions.
Nice. Okay. So let's go there. Okay. Thanks a lot.
Thank you.
As soon as I'm
Thanks.
done, I'll be able to.
We go around here. All right.
This is Johan Stelzer. He's actually from Europe, so you might have met him at.
Hi.
Hello, I'm Johan.
Hi.
Nice
So
to meet you.
So who are you? Johan, you said, yeah. So what are you going to show here?
Yes, I'm Johan. I'm marketing for the automotive product group at Microchip, and I walk you through basically the demos that we have
So
here.
Microchip is in a lot of automotive solutions?
Microchip is in many automotive solutions. I would say countless. Basically, we are one of the lead suppliers basically for touch applications, touch solutions in automotive. And what you see here is an example of touch buttons on a steering wheel with feedback depending on customer requirements.
Is it
and
haptics?
feedback. It's haptic feedback. Yeah.
Nice, looks nice. So you can feel you've touched it?
You touch it and you get some let's say feedback that you actually hit the function.
It's not localized haptics, right? Is the whole unit moving, or is it local?
It's localized. It's
Under your
basically
finger?
On the finger, yeah. If you touch
Nice.
next to it, it doesn't actually move. Yeah?
How does
So
that
if
work?
It uses piezo, let's say, feedback, yeah. And on top of that, it's a surface. The surface is actually, you can program it and to show more functions or reduce the functions depending on the user.
Nice.
So that's what we call one touch, one-dimensional touch. Then we have here a three-dimensional touch, which is basically gesture recognition. You see here I'm entering with the hand into the let's say electric field, and you can see it follows basically my finger. You can see that it shows the four. So actually the five antennas and the field of strength.
How does that work?
We basically we have antennas here, we create a capacitive field, and when I disturb the field, it actually shows the disturbance, yeah.
And is this accurate enough? It could be in a car?
It's in a car, it can be in a car, yes. It can be in cars. A different technology is used today, which is camera based and which is infrared based, which is a lot more expensive. So that is.
So it's more accurate to do it like this with the capacitive field.
Yes, it's more accurate, and it's basically it actually focuses on the gravity, on the center of gravity of the object that gets into the field.
How big is the area you can support right here? It's just around here.
Basically, it's the area is within the field. It's created by the antenna. Yeah. So depending on what size of antenna you're using.
But from
It is 15 centimeters,
From
15
here.
to 20 centimeters. Yeah.
from this distance around.
Right.
That's really cool.
The third technology that we show here is a touch display, and we show here the first time basically knobs on display. So basically it's a mechanical knob. It has one connection to the display, which is this. This is the only electrical connection it has. and it allows us basically to give it feels like a mechanical wheel, but it's actually connected to the
Capacitive display, and it's got like a nice mechanical feeling to it.
It's got a nice mechanical feeling. These two together represent. You can change different things. The interior can be different. It can be just
Nice.
like for example, like your HVAC system. Now they are unsynchronized. You can synchronize them. You can actually have different menus on the.
Just one big tablet.
It's one big tablet.
You screw them on.
Put them on.
Put them on. Put on top of the tablet, basically.
Put it on top of the tablet.
Even potentially take them off.
No, once it's on, you cannot take it off. It basically stays there. But you could have different options. Yeah, you can have let's say, a low-end version without that mechanical wheel, using the same display, and you can add that display or add that wheel in a higher level. Yeah. So basically, this is the, let's say, in general, the touch area. One-dimensional, three-dimensional, two-dimensional touch. And here we show an evaluation kit to continue that. In the corner where we have customers right now, we show basically security technology. We show it on a CAN network where basically messages are protected, secured. We use an authentication to allow only messages that come with the right key and communicate with the right key between the nodes.
This is a big challenge to keep all these cars safe from hackers, right?
Absolutely, that's what we show basically over here.
Maybe we can come back right after.
And
on here?
Here is we show inductive sensing. Inductive sensing. An example of an application is shown here. You see our IC, the inductive sensor IC. You see basically a linear, let's say, sensor here that creates a field to sense the position.
Position of the coin?
No, the coin is just a relative for the size. Yeah. So basically, we have a programming kit. We have the sensor in here. We have a chip. Right there. And we have the communication interface, which could be, for example, PSI5 communication or PWM communication to a main unit. This is why is this needed today? We have already Hall sensors, yeah, but this is a lot more robust than Hall sensors. And then when you look at what's happening is you have more electrical cars. Electrical cars create more, stress, more let's say, emissions. And with this technology, the inductive sensor technology, you can filter better on the signal and work, robustly in this environment.
Nice.
What we have here is MEMS technology. It's laser technology. And basically it's a MEMS mirror, and in the Microchip, let's say, solution is driving the MEMS mirror with MOSFET drivers and providing the intelligence, to control the MEMS mirror.
This is to do the heads-up display?
It's heads-up display, applications heads-up display, but also lighting, yeah, so RGB lighting. Yeah. What we show here is a technology called isolate. It's basically a low-cost solution for interior lighting. What Microchip provides is we provide the microcontroller with an isolate firmware to drive the LEDs. It's the master. Should be here.
What is isolate?
Isolate stands for Integrated Smart Embedded LED. It's a technology that was invented by Innova and BMW,
What's it for?
It's for interior lighting, for any, like for example, having background lighting to your knobs that you just saw over there. Could be done by this technology, or if you
choose the color inside the car.
You can choose the color inside the car out of 4,096 different colors. What we show?
Networking for cars, right?
This is networking for cars for interior lighting. This is networking, classical networking, CAN networking.
Nice. The latest with that. You're doing mesh with it or no?
What we show is CAN partial networking. We have a network where in a normal car, not every node is active at the same time. Some functions are dormant while you're driving, some functions are active. This technology that we're showing here is called CAN partial networking, and allows you to wake up nodes on demand when you need them. And what it does to the user is, let's say, reducing the power consumption of the overall vehicle. So at the end of the day, you're actually saving energy. And that boils down at the end of the day to saving energy on your fuel emission, on your fuel consumption.
Can we jump in there?
Here we show our car access.
Car access.
It's basically it's basically a remote keyless entry. It's passive entry, passive go. PEPS system. And the system that we have set up here is basically you activate the system with the capacitive sensing technology here on the door handle. Now your system wakes up from dormant, from sleep mode in active mode. You basically communicate with your key and your key fob and the onboard unit, and you can without removing basically your key from your jacket or from your suitcase. You can enter the car, you can start the engine, press the start button, and you start your car. What Microchip has is one of the challenges here is basically that someone on the challenge with PEP systems is someone could actually let's say read your key while you're actually, let's say, in the restaurant or at home, and use a router to actually open up the car that is distant from your key.
And you have a solution to make that
we have a solution for that. Yeah.
Nice.
Yeah.
That's a big deal. You don't want people to steal your Tesla.
Absolutely. Yeah. Moving on to the next one. This is wireless charging.
Nice.
So what Microchip has is a number of let's say products that go into the wireless.
So the Qi wireless charger and high power, very high power wireless charging.
Yes, for automotive it wouldn't be 100 watt. For automotive, basically we're targeting 15 watt. That's what basically the phone maker, the smartphone makers would accept. Our system is again is flexible to be able to adopt the various profiles of the different let's say mobile and smartphone makers, whether it's Samsung or Apple or Huawei, can be adopted to their requirements.
Nice. What is this?
This one is USB power delivery. So this over there we saw the wireless charging. Here we see the wire charging, basically.
Nice.
Via USB interface. And what we show here are the different types of charging profiles that we can support with our products.
Cool.
Another
power delivery?
This is another element of basically power delivery, USB charging, but also Flex Connect or road reversal. So, for example, this solution supports CarPlay and CarLive, where basically your phone takes over control of the navigation system or the head unit. So you probably know about this, when you plug into the the USB port with your iPhone and you go into CarPlay mode, basically on the display on the head unit in the car you see basically a mirror of your cell phone, of your smartphone. All the applications are available now.
So it's DisplayPort? This is
Yes.
the DisplayPort output to the display.
Yes.
So you do the chipset that does power delivery and DisplayPort,
Right.
power. So
Exactly.
and
So
data.
this one does both data and charging. This one is charging only. Yeah? So this is, what we show here is a secure Ethernet application. And I mentioned earlier over there that security is a key point for any networking system or any network in the car. So what this solution shows is an Ethernet network with different nodes and paired with our security IC, provides a robust, secure solution. We not just rely on software TLS, but also do hardware TLS here.
What is CoaXPress?
CoaXPress is a standard that is being used in industrial application today. Microchip has been in this market for the last 10 years as a key supplier of this technology in industrial applications. Now we are making this solution ready for automotive applications. So that means automotive qualification, but we also provide solutions with automotive standards like MIPI CSI2 interface to camera ICs and back to the main unit. So that gives customers multi-gigabit, in this case 10 gigabit power, 10 gigabit speed.
In a small cable?
In a coax cable. Yeah? So this is
all over the car.
A 15-meter coax cable with, these are inserts, basically with, you can have four, let's say, four inserts in a 15-meter cable.
Up to 12.5 gigabits per second.
That's correct. Yeah. That's the industrial speed. For automotive, the speed is right now 10 gigabits per second.
Nice.
What we show here is an iNickNet. It's a technology that combines basically synchronous network and Ethernet. This particular demo here shows an Ethernet network connected to the iNickNet. On the same bus we have streaming data, we have audio video data, but also we have packet data, we have Ethernet data. So anything that comes from the Ethernet can go seamlessly basically into those nodes. We could be for example head unit or an amplifier or a telematic unit.
Because all these cars have more and more networking going on.
Right. There's more and more networking.
Big jumps to new cars have much more faster network.
Well, they actually have many of the cars have IP-based networks, Ethernet, automotive Ethernet. Yeah. But for some applications, iNickNet is a much more cost-efficient solution because it actually can work with native data, streaming data, especially for audio and video applications.
Nice.
So we show a variant of this iNickNet here, which is
with voice?
With voice recognition and with microphones. Those microphones, for example, could be used for emergency calls, of course, but also for noise cancellation within the car. And again, real-time speed is critical. Streaming data is critical. This is where this iNickNet is, let's say, is superior over other networks.
It could be Google Assistant and Alexa in the car
yes,
too, right?
Exactly. That can be connected with that.
Right. And yeah, and then just this demo there.
So we're not filming
showing this
the
one.
demo
Okay.
because it's,
Okay, but how about that one over there? Can we get the
I can go back. Sure.
Let's get this one. Yeah. So this is how you make sure that the cars don't get hacked.
This is our an example of our security application. Yeah? This is a CAN network, and messages are being, let's say, sent around between the nodes.
Yeah.
These are the three nodes. But imagine someone is, let's say, hacking the system, for example, through coming in through your telematic units, and changing basically the data that are communicated between the nodes. Yeah? So your speed could be shown wrongly, or let's say the RPM could shown, but you actually could let's say stop the motor from external, and with let's say authenticated messages that can be prevented, and we have the solution that
Authenticate CAN, because CAN is kind of like an unencrypted open networking thing.
Exactly. Yeah.
It's very easy to hack
Messages
right now.
messages are not encrypted, first of all, yeah, but you can encrypt them with this technology.